this is Anpit Chand. Welcome to my mathematics class. Today you are going to study limits of trigonometric functions. Part 3. Already I have made video on this functions, trigonometric function, part 1, part 2, and in part 3 I have taken very important questions. These are very important questions. If you know how to find out the limits of these functions, then you can be ace in finding the limits of trigonometric functions. Okay, I hope you will be definitely perfect in finding these questions, and you will enjoy. I will tell you in a very simple way, okay, very simple method. These are all questions of same type of questions. I have taken here 5 questions of same type, and answers also I have written here. I will tell you the one or two question. Thereafter, you can do very easily, very comfortably. If you get any problem, please don't hesitate to ask the question. Just write down in comment box. Definitely, I'll reply of your question. So I like, okay. I would love if you comment. Okay. Now here we go. I'm going to start from here. One first solution. Limit of x sine theta minus theta sine x over x minus theta, x tends to theta, right? As x tends to theta. And if you see very carefully, then you can say from 0 upon 0, okay, from 0 upon 0, because x tends to theta. Here theta sine theta minus theta and sine theta, this becomes 0 as x tends to theta, and x minus theta also becomes 0. So 0 upon 0. Alright. So next step, what will be the next step? We will do some arrangements. Okay, we have another also method. Okay. Not to make your noise, okay? Go there and then pay attention. Why don't you understand what happened? ये कि वो भी loudly not. Here. See the next step. A very simple arrangement I will tell you. Limit as x tends to theta, x sin theta minus. Okay, let me write down with red ink, pen, minus theta sin theta plus theta sin theta. Okay, just you have to add and subtract, okay, this minus then theta sin x. This is a theta, the same thing. Here given already in numerator, this part is also given in numerator. I have just, okay, subtracted minus this one, my minus theta sin theta, and added, okay, this whole expression with this, okay, theta and sin theta term, okay, and they will be cancelled. So numerator becomes equal to the numerator. There will be no problem in numerator. Okay, so we can do. And here in denominator same, x minus theta now is equal to limit as x tends to theta. In numerator you will just, okay, common from here, common here also common. Here what you will get common here, x minus theta and sin theta common, okay, and mine here plus theta. Inside the bracket you have sin theta minus sin x. This is sin x over x minus theta. Now clear? Is equal to limit as x tends to theta. So very interesting pattern we are going to get here. X minus theta sin theta, big bracket I am using, over x minus theta. Okay, so here plus theta sin theta minus sin x over x minus theta. We can write down this whole expression in this form. All you know it's easy step. Now we will write down this separately. Limit of this function plus limit of this function, as we have studied already in limit theorem. If we have a limit of f of x plus minus g of x, then we can write down limit of f of x plus limit of g of x. The same I'm writing, okay, here x minus theta sin theta over x minus theta, although we can cancel this common term, plus theta, because theta is your constant, limit x tends to theta. Here I'm lacking space. Okay, I try to write down sin x over x minus theta. Okay, so this step is also clear. I think you don't have a problem here. Is equal to, okay, we can cancel them because x tends to theta means x minus theta is not equal to 0, and limit of sin theta as x tends to theta, sin theta is your constant, plus, so I'm making little change here, minus, I'm taking common outside, as x tends to theta, here I am writing sin x minus sin theta over here. Listen to me. So from here minus sin taken here actually sin theta minus sin x, I have taken minus common from here, that minus I have written this side. If we take common minus, then this expression becomes sin x minus sin theta. Okay, x minus theta. Alright. So limit of sin theta as x tends to theta is your only sin theta is equal to simply sin theta, because sin theta is constant, minus theta. Here you will use, okay, formula sin x minus sin theta. What we can write on sin c minus sin d. Okay, okay, sin c minus sin d. Here I am writing from sin c minus sin d. Sin c minus sin d formula to sin c minus d by 2 cos c plus d by 2. Okay, this is a formula. Sin c minus sin d is equal to 2 sin c minus d by 2 cos c plus d by 2. Okay, I'm using this formula here. Using this formula, we will get here 2 sin c minus d by 2. This is your theta, and cos x plus theta, here theta, by 2 over x minus theta. Okay. Now next step will be your, I'm writing here, I'm erasing this part, I need some space. Okay, so after this you can see here is equal to sin theta minus theta. You can write down limit as x tends to theta. See very carefully this line here, sine of x minus theta by 2 and cos of x plus theta by 2 over whole upon x minus theta upon 2. See here very carefully, x minus theta upon 2. So this two I brought again upon of this one. It goes okay in numerator, so same thing will same okay. So this expression is equal to this expression. There is no problem. So 2 may go off, right? So don't get confused. Sine theta minus theta. Now you can write a limit. So I'm writing it separately. X tends to theta. Okay, and sine of x minus theta by 2 over x minus theta by 2 into, okay, let me write down, okay, bracket, okay, we can write down, okay, we can write down separately a limit as x tends to theta cos x plus theta by 2. So I'm here erasing because I need space, going to expunge, plus theta by 2. This is a, using the limit theorem we can write down this, okay. So I'm going to erase this part here because I want to write down the solution, okay. And so after this you can write down here sine theta minus theta. So let me write down x minus theta by 2 tends to 0. We can write down because x tends to theta means x minus theta tends to 0 and by 2 also tends to 0. Sine of x minus theta by 2 over x minus theta by 2 times, here lack of space, I am writing okay here limit, this part is here, I am writing here limit as x tends to theta cos x plus theta by 2, okay. And is equal to sine theta minus theta, this becomes 1 and this becomes your limit of cos theta as x tends to theta, theta plus theta by 2. So simply sine theta minus theta cos to theta by 2 means theta. So this is the limit of this function. Now you understood how to find out, okay. Now I will tell you this one also, okay. This I have done, and if I do this one, okay, then you can do, I have done, so you can. And these two are also similar type of, thereafter you can try to find out the solution of this question. Now I will tell you the solution of this one also, okay. So you can go through this. If you have any problem you can write down in comment box. Now okay, now let me start the solution of this one. Second question. Solution, limit as x tends to theta x cot theta minus theta cot x over x minus theta. Okay, same type of question. Here also we will do the same type of arrangement as x tends to theta. Here I think now you understood. You have to subtract theta cot theta plus theta cot theta minus theta cot x. Okay. I couldn't get space here. Let me start from here. Is equal to limit as x tends to theta x cot theta minus theta cot theta plus theta cot theta minus theta cot x over x minus theta. If you see, then you will find out 0 upon 0 form means indeterminate form. Okay, here we have added and subtracted this term. See very carefully this one. Alright, now we have to take here also common same cot theta. Common from here also theta common. Okay, the same method we can use is equal to limit as x tends to theta, uh, x minus theta cot theta, okay, plus theta, and inside the bracket cot theta minus cot x over x minus theta. Okay, now let's write down separately. Is equal to limit as x tends to theta, x minus theta cot theta over x minus theta, simple thing, you know this, plus here theta bracket cot theta minus cot x, this is a cot x, over x minus theta is equal to limit as x tends to theta. We can cancel this. You will get simply cot theta plus here theta cot theta minus cot x over x minus theta. Alright. Now limit of this plus limit of this one is equal to same method, exactly the same method you have to use. Cot theta plus theta is your constant, so we can write down outside as x tends to theta cot theta minus cot x over x minus theta is equal to limit of cot theta as x tends to theta cot theta, because cot theta is a constant, theta is constant, plus theta limit x tends to theta. Here see very carefully, cot theta minus cot x. We don't have a formula like sin c minus sin d, sin c plus sin d. Okay, we don't have a like that type of formula. If you get okay cot and tan, then just try to convert into sin and cos. Okay, cot theta we can write down cos theta upon sin theta minus cos x over sin x and x minus theta. Here cos theta upon sin theta minus cos x upon sin x whole over x minus theta. Okay, so after this I'm going here, cot theta plus theta limit as x tends to theta, you can take LCM, you will get here sin x cos theta minus cos x sin theta over sin x sin theta whole upon x minus theta. So simple, is equal to cot theta, okay, plus theta as limit x tends to theta, and here I think you understood. I'm going to erase here because later I need space. Or limit as x tends to theta, here you will get, this is in formula sin of x minus theta and x minus theta, and this will come down here sin x sin theta, and now I'm writing here cot theta plus theta limit, we can write down separately, x tends to theta sin of x minus theta over x minus theta into this part I am writing here limit as x tends to theta 1 over sin x sin theta. Okay, I've just applied limit theorem, is equal to cot theta plus theta. Here this is a 1, you can see, because x tends to theta means x minus theta tends to 0 using limit which one limit theorem, let me again, limit sin of x over x as x tends to 0 is equal to 1. already I have explained, proved, and we have done many questions, okay, in my earlier video. And here sine x becomes sine theta is already constant, right? And you will get here cot theta plus theta times 1 upon sine square theta, okay? And finally you will get here cot theta plus theta cos x square theta. So this is the limit of this function, okay? Now I think you fully understood how to crack down these type of questions. Now it's easy for you. You can very easily find the limit of these type of trigonometric functions, okay? So thank you for watching my video, and I have left these questions for practice. Please practice and try to find out the limit of this function. If you don't get anyway, if in any case, please don't hesitate to ask the question, to ask the solution, or to ask the any step of the question. You just write down in comment box, immediately you will get reply of that question, okay? So once again, thank you for watching, and thank you stay with my channel. Okay, bye bye, see you.